So far in this course, we've talked about the coding environment and the general syntax for R. In this next section, we'll be talking about data structures. Firstly, a vector is a linear collection of data. All elements within a vector must be of the same data type. For example, we can have a vector of names assigned to the variable name. Here, all elements within this vector are character strings. To put this vector together, we use the concatenate function. Note that the hash here is a comment on this particular line of code. Next, we can also assign a vector of numbers to the variable age. Here, we concatenate different numeric elements into a numeric vector. It is important to note that in R, operations are vectorized. What does this mean? For example, if we take the numeric vector age we defined earlier, and we subtract 5 from it, every single element will have 5 subtracted from it. Here's another example. If we add together two vectors, the first element of vector 1 will be added to the first element of vector 2. The second element of vector 1 will be added to the second element of vector 2, and so on. For example, the first element of age was 20. 20 plus 20 is 40. The second element was 25. So 25 plus 25 is 50. The next type of data structure we'll talk about is a list. Now, lists, like vectors, are also a linear collection of data, but they are very flexible. They can contain different types and structure of data. For example, we can create a list with a mix of data types and variables. Recall that earlier we created a character vector of names as well as a numeric vector of the age of these different people in names. So to create a list, we can use the function list, and in this case, create a list of 4 elements. So this first element would be a vector, this as well, and in this third element, we have a character string, and the fourth element would be a numeric element. We can assign this to a name called my team. And when we print out this list, note that elements in a list are indexed with double square brackets, meaning that this is the first element of the list, this is the second element of the list. You can see that this first element is a character vector, the second element is a numeric vector, and so on. Moving on, let's talk about factors. Now, factors are vectors as well, in that they are linear data, but they're kind of special. They only represent categorical data with discrete levels. So think of things like eye color. You have blue, brown, black eyes, and so on. Think of binary data like biological sex. You have male and female. Think of ordinal data with a sequence. For example, when you take a survey, you're often asked if you strongly disagree, agree, and so on. All these are categorical data with discrete levels. For example, we can code the sex of each person in the variable name. So this was the character vector we coded earlier. To create a factor, you use this function factor, and in our example, you can code either male or female to each person in name. When you print out the object, you'll notice that there's an extra line of output that tells us about the factor levels that are present. This is another example for ordinal data. For example, if we're interested in the performance of each person, we can have a factor variable representing medium, high, or low performance. However, one thing to notice is that the order of the factor levels by default are arranged alphabetically. So this would mean that the sequence is wrong. To specify the order of your factor levels, you must include an additional argument in this function. And in this case, we can, for example, arrange the factor levels by ascending order, so low, medium to high. Next, let's move on from one-dimensional linear data to two-dimensional tabular or rectangular data that have rows and columns. A matrix is the most basic way to represent tabular data, and all elements of the matrix must be of the same data type. For example, when you capture an image using a camera, the image is represented by a matrix of pixel values. For a color image, you have red, green, and blue, or RGB. So you actually have three matrices representing the intensity of values for each of these three colors. In R, you can create a matrix using this function matrix. And in this example, we can create a sequence of numbers 1 through 12. Note that this colon allows you to create a sequence of numbers from this number to that number. In this example, we create a matrix of 4 rows. In the output, note that this is the index of rows, and this is the index showing the column numbers. Finally, let's talk about data frames. Data frames are also tabular data with rows and columns. Typically, each row would represent a data entry, and each column will represent different variables. For example, recall that in an earlier video, we imported the dataset ozone_data.csv using this function read.csv. So if we do that and assign it to this object called ozone, we can view the first few rows of this dataset ozone using this function called head. And here you will notice that we have rows representing multiple data points for 4 different variables. So for example, this was probably radiation, temperature, wind, and ozone. 4 different columns. We can check the dimensions of this tabular data using this function dim or dimensions. It is important to note that in R, when referring to tabular 2-dimensional rectangular data, the first number always represents rows and the second number always represents columns. So in this case, we have 111 rows or data points and 4 columns. We can use some of these functions to check the names associated with this dataset. For example, we can get the column names or call names for ozone, and we'll get a character vector of the column names. Also, we can extract data by their column name. For example, we can extract the temperature data by its column name, and we will get a numeric vector of temperature values. Let's finish up with our example. Recall that we had 5 different vectors that we created earlier. We had 5 names, 5 numbers representing the age, we had the sex, and the performance of these 5 different people. We can use this function data.frame to combine all these vectors into a data frame and call it, say, team details. So here, each row represents a data point or an individual, and we have 4 different columns or 4 different variables. Let's demonstrate this in R. I want to clear my previous work, create a new code chunk. Here, I create 2 vectors, one for name and one for the age of these people. These 2 lines of code will create firstly a character vector of names and a numeric vector of their age. You'll notice here it says character and here it says numeric. Both these vectors are of length 1 through 5. At this point, I want to demonstrate something called coercion in R. For example, what if we replace Harry with a number and run this line of code? Notice that the number is actually treated as a character string. And in the environment, this is still a character vector. So the numeric element is coerced to become a character string. This is what is meant as coercion in R. Let's undo this. What if we add a character string to a numeric vector? Notice now that this numeric vector has been converted into a character vector. If you print it out, all these elements will now have double quotation marks. In this case, this numeric vector has been coerced into a character vector. Let's undo this. And finally, let me demonstrate what happens with logical data. Notice that this logical data true has been coerced into the value of 1, and the logical data false has been coerced into a value of 0. So do remember that vectors must be of the same data type. So if there are multiple types of data within a single vector, coercion will happen. Let's undo this and rerun this code. Finally, let's add these 3 lines of code. So we have the sex, the performance, and we combine all these 4 vectors into a data frame. Do remember to specify the levels for your factor. You'll notice here that the data frame is under this header data, while the vectors are under this header values. Notice that for this new data frame you created, you can click on this arrow to inspect the different columns as well as the data types that they contain. You can also click on the name of the data frame itself, and it will open up in a new tab where you can inspect the different rows and columns. Alright, that's it for this video on data structures. In the next video, we will go back to looking at some operators in R. Specifically, we'll be looking at how to subset data in R. See you in the next one.